Hello, in this video tutorial we will look at a function that is called design option. Let's first consider the purpose of this function. Design option enables to perform in the same problem the analysis of the model with different design characteristics calculated according to different codes and different parameters of materials. Let's look more closely at this function on an example. We have a modeled three-dimensional frame with the floor and the specified stiffness values for elements and loads. In order to create one or more design options, use the command design option for main model in the design panel. In open dialog box, you can create the necessary number of design options or remove the unnecessary ones. You can also select built-in codes for each design option. In addition, you can select the type of analysis, whether it is analysis for DCF, DCL, or just for forces. If necessary, you can name each of the design option. In this problem, we need to create three design options. The first one will be performed according to SNP 84, and this analysis will be performed for DCF. The next two design options will be carried out according to SP 2012, and the analysis will be performed for DCL. Let's now save our design options and close this dialog box. Let's open another dialog box, which is called Material Properties of Reinforced Concrete, in the same design panel. In open dialog box, we will create three types of parameters for reinforced concrete structures. Let's start with the first design option. First of all, we have to set it as current. This operation can be done in two ways. In the first case, you can change the design option directly in this dialog box. And in the second one, you have to use the status bar. Click the button with the list of design options near the image of the hammer and select the first design option. Thus, firstly, we have to set the general parameters for the column, beam and floor slab. Once we have set all the parameters, the next step is to select material properties for concrete and reinforcement. For the first design option, we have to set the class of concrete B25. And then we have to set the class of reinforcement A3. Next, let's select the second design option for SP 2012. Similarly, we set general parameters for columns, beams and the floor slab. In this case, we will use class of concrete B25 and the class of reinforcement A400. Since the third design option used the same built-in code as the second one, we can set all the parameters without changing the current option. Thus, we only have to specify a new class of concrete B15 and a new class of reinforcement A240. Now it is necessary to apply the parameters from three design options to all elements of the model one by one. In turn, for each option, select structural elements for which you want to apply the parameters. For instance, let's apply the parameters for the third design option. Firstly, apply the parameters for columns. Then for beams. And finally for slabs. Once all the parameters are successfully set, it is necessary to create DCF and DCL tables. In our problem, all the tables for DCL and DCF for both built-in codes have been created in advance. Finally, we have to perform the analysis. Once the analysis is performed successfully, open the Design tab and analyze the results of reinforcement selection for each of the design options. As it is seen from the analysis, The first and second design options have produced approximately the same result of reinforcement selection for the floor slab, and the third option shows more reinforcement, since the class of concrete and reinforcement was lower. Similarly, we analyzed the results of reinforcement selection for columns and beams. Ultimately, it's up to the user to choose which options suit him better and which he will use. That is all. Thank you for your attention. We are looking forward to your comments and suggestions.